I will always start notes the same way. I will always begin by putting the date up in the corner. This helps if you're going back and watching an older video. So today is 8/28. And I try to keep my handwriting good. That's I try. So if you ever can't read something, just let me know. So what we're doing today is we're learning or perhaps relearning how to solve one-step equations. Over the course of the next week or so, this will spin off into 2 steps and then 3 steps, like equations where we might have to distribute, combine like terms. We'll even see 4-step or 5-step equations eventually. Equations where you have to distribute, combine like terms on both sides of the equals and move things across the equals. So they get more complex, but today the mission is that every one of these that I've written that you're going to do can be done in just 1 step. All right. And before we start, just so you know, I will expect you to show your work on equations up until a point where you've demonstrated repeatedly that the process is so robotically ingrained in your brain that we no longer need that. There will come a point, it's usually October something, where I say, like, kind of let you have a little freedom so you can start seeing things and solving them mentally if you're prepared to do that. But for now, we're going to follow the exact steps that we see in the notes, okay? So I started us off with the easiest example I could think of. Well, that's not really, I could have probably gone a little bit easier, but this is what I came up with. Do you guys know what it means to solve an equation? Yeah, to find out the missing part. Is that what you said? Yeah, sure. And X is the missing part, right? There's only one number in the world that I could put in place of X in that problem and make the left side say the same thing as the right side, right? Like if I put in 1 for X, you don't have to have a math degree to see that 1 minus 4 is not the same as -9, right? So solving equations is the hunt for the number, or later this year, the numbers, when we do quadratics, the number or the numbers that make the equation say something true. So do you guys know from your past experiences how we solve this? Not what the final answer is, but what do we do, Gage? Right. So our mission is essentially, you're going to hear me say this probably 200 times, get the variable by itself. So it's over on the left side, but it's got this pesky -4 with it. And how do we undo a -4? With a +4. Right. So we're getting rid of a -4. And what we're going to do is we're just going to simply put a little +4 underneath it, head to the other side of the equal sign and put a +4 underneath there. It is important when you solve equations that whatever it is you're doing, you understand that you're doing that to both sides of the equal sign. Later on in class, we're going to multiply both sides. We might divide both sides. We might subtract on both sides. But the key is that equity, that I'm keeping and like in science, those silver platters, where if you add something to one plate, it goes down like that. The goal is to keep balance continuously throughout the problem. So the next thing we're going to do is we're going to cross out these are called inverse operations, and we're going to drop down the X, and we're going to drop down the equals. Notice I dropped it down before I even worried about ever doing math, right? Don't get ahead of yourself and worry about what the answer is. Just set it up like structurally, step along the way as you go. And now you do a little bit of math. What is -9 plus 4? Always -5, always has been. And if you want, I'm at a point in my career where I don't make you do this anymore, but if you want to know if it's right, you can always take your answer. Again, this is up to you. And you can plug it back into the original problem and just see, does that make sense? And it does. -5 minus 4 checks out. So that last part is up to you. Any questions about that? Okay, let's go again. Next one, we have -13 equals m plus 19. And you want to get used to not always using X's. I use X's a lot, but I'll try to branch out and throw in K's and M's and N's and W's and stuff like that, because it just doesn't matter, right? All right, so the operation is to get n by himself. What are we going to do to both sides? subtract 19, right? Common error is people add 13. And I'm always like, what are you doing picking on that guy? Like, he's not over with the M. So we want to take away 19 right there, close it off, take away 19, close it off. And then this part of the problem takes like 2 seconds, but it's not doing math. It's just like housekeeping stuff. I'm going to cross out the 19s, the inverses. I'm going to bring down the M. I'm going to bring down the equals. And now we do the math. And this is, again, what you see every day. You can't get away. If you're still one of these people that thinks negative 13 minus 19 is like, I don't know, 6 or something creepy like that, it's just going to be a hindrance all year. What is down 13, down 19? Negative 13 minus 19. It's exactly negative 32. Very good. And again, so at some point, you and your brain have to come to some consensus about how can I make that make sense for me? How can I understand that Sally, the scuba diver, is already 13 feet underwater, and if she swims minus down more 19, that's where she's at. It's really just an addition problem in the backwards direction. Yes, ma'am? You like putting the variable on the left? You're welcome to. You'll rarely see me do that because I hope you get to a point where you don't care. I would like to kind of coach that into you, that the variable can be on either side. But if you wanted to rewrite like the original problem like this, you can. I personally think it's a waste of time. So I'd like you to get to a point where you don't have to, but it's certainly not bad if you do. Okay? Because you're going to see equations where there's variables on both sides, and then you're like, whoa, you know what I mean? So just kind of get used to it. All right, you good on adding and subtracting? All right, and I'm going to really be a stickler here for at least a month or so about your work and it being meticulous and every little detail shown until we can get that thought process just stuck. What is actually happening? Get it stuck, right? Next one. Clearly, you spot the variable and you spot the annoyance. You say to yourself, why is my variable not yet by himself? Who's picking on the y? That dang 4. And what exactly is he doing to the y? He's a multiply 4. And how do we kill a multiply 4? With a divide 4. So from this point on, in your math life, algebra 1, algebra 2, geometry, pre-calculus, calculus, college math, I don't care. I speak for all of us math people. Division shall be shown in this format. We're not going to go like off to the side and put little division signs and stuff. Downwards work with the only one where we're ever going to go sideways, you'll see in the next example, is times. Okay. So divide by 4. Again, housekeeping, cross out the 4s, drop down the y, drop down the equals, get the landscape set before you worry about the basic math. What is negative 24 divided by 4? Perfectly negative 6. Done. Right. Equations are nice because if you want to, you can like grade your own paper before we even, it's like a quiz. You could grade it before I grade it. You know, you just put your answer back in and see, it works. It must be right if it works, right? Right. Next one. What are we going to do to both sides this time? We are going to multiply. Very good. It's always this process of who's the number I need to get rid of? Like, what's his current role and what's the opposite of that or inverse of that, right? And the opposite or inverse of dividing by -8 is multiplying by -8. And again, from this point on in your math life, multiplication shall be expressed with parentheses. That parenthesis stuff is important because it tells the world, hey, I'm encapsulating this whole equation. Everything inside of those red parentheses is going to be multiplied by -8, like this. Housekeeping part of the problem, which again, for those of you who hate this kind of stuff, just ride it out with me here for a little while. And then before Halloween, I'll probably have it to the point where, hey, yeah, just do it in your head. All good. So parentheses, multiply off to the side, cancel out your -8s, drop down your variable, drop down your equals, and then do the math. What is -8 times -5? Perfect. So that's the introductory part of the lesson. Those are as simple of one-step equations as I could come up with. My last 3 examples involve fractions, and you cannot get away from them. These all still can be solved using one step, just for the record, okay? And if you don't really like fractions, that's okay. It's okay to hate fractions. You just have to learn to peacefully coexist with them. Can't get away from them. For our next one. There is a way to solve this as a 2-step equation, but because today's lesson is on 1-step equations, I'm going to stay true to that and show you how you can do it in just 1 step, just 1 move, boom, game over. What number are we trying to kill? That 4/5 has got to go. What do your instincts tell you should do to get rid of him? Divide. And that's not right. And listen, it's not wrong either, but it's not the best way. I shouldn't say it's not right. There is a better way than dividing, because if you divide, you got to divide by a fraction, and then you get into that whole copy dot flop thing. So what I'm going to show you here today is, rather than divide, contrary to what you might think, we're actually going to multiply. So come along for the ride here. Can you think of something that I could multiply 4/5 by that would make it essentially disappear? You've done it before, you just don't know. You don't remember right now that you've done it before. Have you guys ever heard of reciprocals? Yeah. What's the reciprocal of a fraction? Any fraction. What do you do to find a reciprocal? You ever heard of that? Like 2/3 is reciprocal is whoop, 3/2. Remember those? It's flip-flop, right? So what we're going to do is multiply by the reciprocal, because watch the magic that happens if we multiply by the reciprocal. So we're going to flip the target fraction, the 4/5. We're going to flip them over, and we're going to multiply on both sides. And the beauty of this is that over here on the left side, we accomplished exactly what we set out to accomplish. Namely, look at the 5s. Cancel. Look at the 4s. Cancel. Proof positive. I have now gotten X by himself. Done. So the algebra teacher in me says, I'm done. My work here is done. But now we, again, cannot avoid that stuff that was on the basic skills tests. And that is, do you know how to work with fractions? So when you think about the multiplication, that white and purple multiplication problem that's over on the right-hand side, what's the first thing you register as, Houston, we have a problem? 32 is not a fraction. That -32, I'm going to go off to the side here and show a little bit of work, needs to be expressed as -32 over 1, so that he has the ability to interact, multiply with another fraction. I would simplify it, Alana, for sure before I multiply it out. And what do you see from the top and the bottom that can be simplified? These yellow numbers can both be divided by. So the 4 becomes a 1, and the 32 becomes 8. And at that point, all the simplifying is done. You always know you're done when you got 1s on the bottom, and you're not going any further than that. So let's just sweep across the top. What's -8 times 5? And there is your solution. Yeah. Oh, yeah, totally. I'm so sorry. Yeah, anytime your pass says 8:10 and you need to go, just peace out. You don't need to clear it with me. You're so polite. I appreciate that. But just get caught up to the video tonight sometime. You'll see it on Canvas, and then just fast forward to this part because we got a couple more examples. And the assignment is on Canvas. You'll do it on a separate paper, like notebook paper, and it's not due tomorrow. So maybe just put in about 10 or 15 minutes on it tonight. You're welcome. Bye. That's a little harder, right? Any questions on that? So when we see that fraction in front, our heart's going to tell us we should divide because it's a times fraction, but we're going to go, no, I got a quicker way. I'm going to kill that fraction with the times by the reciprocal. Let's practice that again, because I have a feeling that some of you maybe didn't love that problem. So let's go round 2 on that. let's do negative 3/4 of W equals 9/8. Again, by definition, we're going to say I should divide, but we know better. What is our quicker route to success here? Multiply by negative 4/3. Very good. This red number that I wrote up here has to accomplish three things. It has to have a negative in it to cancel the negative on the fraction. It has to have a 4 upstairs to cancel the 4 downstairs and a 3 downstairs to cancel the 3 upstairs. So you got to go kill the negative, kill the 4, kill the 3. So everyone is present. Good job. So we're going to do that on both sides. Housekeeping part of the problem. Cancel your 4s, cancel your 3s, cancel your negatives. Bring down your variable. Done. Basic skills test. I don't have to go off to the side to show work this time because I already got a fraction and a fraction. What do you see that can simplify? Sure. So let's pick one of those. Let's do the 9 and the 3 because you said those first. What can they both be divided by? Very good. So I'm going to cancel them both by 3, resulting in a 1 and a 3. And Alana, you also said the 4 and the 8. Okay, so let's get rid of the 4 and the 8. They can both be divided by 4, leaving 1 and 2. Anything else? That's it. So at this point now, it's time to just get your head around what the answer is going to be. First question, is the answer overall going to be positive or negative? It is negative because at the end of the day, I did a positive fraction times a negative fraction. That's a negative. And if you sweep across the top and multiply, what do you get? 3. 3 times 1 is 3. Sweep across the bottom. 2 times 1 is done. Do not put negative 1.5. Do not put negative 1.5. Math teachers love improper fractions. We need to start renaming them as like awesomely acceptable fractions or something. They are not improper in the sense that you're used to, right? Like there's improper attire and improper language and stuff like that. Nothing improper about these fractions. We love you. I have one more example for you. And after this, I think when you look at your assignment, you'll say, we did enough in the notes that I can do them all. We'll find out after this. So for our last example, we have negative 4/5 equals x minus 2/3. I mean, technically, this example could have been earlier in the lecture because there's a minus in there, but I thought let's cover it while we're talking fractions. So what number are we trying to eliminate? That is a minus 2/3. And how do we eliminate a minus 2/3? You add 2/3. You just hit it with the direct inverse. The inverse of minus will always be plus. And so I'm going to, underneath, put a plus 2/3. Close it off. Plus 2/3. Close it off. Always close off those plus and minus. Make it official. On the right-hand side, we're going to cancel out our inverses, the minus and the plus that we set out to kill. And then before we worry about getting all mathy, we're going to drop our x and we're going to drop our equals. Basic skills test to the rescue again. So I'm going to go ahead over here and make a couple of new fractions. What do I want the bottoms to be? This is least common denominator village. They have, what's common to 5 and 3? 15 is the best we're going to do. So the top fraction, the 5 on the bottom, what would you have to multiply him by to make 15? 3. So you take the number on top, negative 4, multiply him by 3. What do you get? Negative 12. And it's still over 15. You reset. Go to the bottom fraction. What would we have had to multiply the 3 by to make him 15? 5. Turning the top 2 into a perfect. Leaving the bottom as another 15. At this point, those two yellow and white fractions are compatible. What is negative 12? Yellow plus yellow. Negative 12 plus 10 is? Done. That should be enough information to get you through. So I'm going to leave this recording going for a second so I can tell you this. So today begins your adventure. Don't fidget too much yet. In a minute or two, we're going to get out our Chromebooks and we're going to go to Canvas and you're going to click on the PDF in today's post and you'll have out your own notebook, paper, and pencil. The problems will be on a worksheet that I'm not making copies of. So you'll just look at the screen, copy the problem onto your paper, solve it over there, and you'll do that. Out of respect for your time, you heard me tell Mila, this is not due tomorrow. So we'll work for about 20 minutes here today, probably get 9 or 10 problems done ish. And then tomorrow I'll give you a full big chunk of work time in class, and then we'll call it due Wednesday. Sound good? Yes, ma'am. Good question. Let me cut the recording and then we'll talk about that.